Good morning, scholars. Today, we're going to talk about puzzles. Have you ever tried to put a puzzle together before? Sometimes it can get really complicated. But did you know that the surface of our planet is kind of like a puzzle? We're going to learn about plate tectonics today and how those puzzle pieces come together and what geological events happen at those boundaries. It's going to be awesome. Now you may be wondering why I'm in a car because when you learn about plate tectonics, there is a place that you have to go. But you won't find out where that is until after this video. Are you ready? Puzzles, plate tectonics. Here we go. Plate tectonics. Here we go. This is going to be fun. Alfred Wegener had a theory of plate tectonics, and it began in 1915. He proposed that the continents plowed through crust of the ocean basins. This theory of continental drift explained why the outlines of many coastlines seemed to fit together like a puzzle. So when we look at Africa and South America, oh wait, they do fit together like a puzzle. That's really cool. There are 7 major tectonic plates that exist on our planet. Tectonic plates are pieces of land that connect to each other on the Earth's outer shell, the Earth's crust. We're going to talk about 3 types of boundaries between those tectonic plates. The first one is divergent, and that's when the plates move apart. The second one is convergent. That is when the plates are coming together. And the last one we're going to talk about is transform. Plates that slide horizontally past each other. First, let's look more closely at divergent boundaries. Divergent structures are formed as plates pull apart. Examples of this would be mid-ocean ridges, like the Mid-Atlantic Ridge, rift valleys, like the African Rift Valley, and of course, earthquakes. First off, the mid-ocean ridge. The seafloor is spreading at divergent boundaries as those plates move apart. The map on the right-hand side of your screen shows different boundaries between plates where we see divergent boundaries. We see the older land going toward the side and the younger being in the middle, the new lava coming up from the mantle. These 2 plates are moving apart. A divergent boundary. The second one that we were going to talk about is a rift valley. As plates move apart, divergent boundaries can create rift valleys. One of those areas is in Africa and Saudi Arabia, where you have the African plate and the Arabian plate moving away from each other, and we see a rift valley form. Now this particular map shows it a little bit better because you actually see that large black line that shows you where the 2 plates meet and are moving away from each other. Okay, convergent boundaries. Convergent boundaries destroy crust and recycle it back into the mantle. We see that in the form of trenches, mountain ranges, and earthquakes. Mountain ranges like the Himalayan mountains and Andes mountains, and of course, earthquakes again. We see that a lot at all of the boundaries of these tectonic plates. Subduction occurs when a more dense plate slides under a less dense plate and sinks into the mantle. We see this occur when an oceanic plate meets an oceanic plate, when an oceanic plate meets a continental plate, and when a continental plate meets a continental plate. Okay, let's look at this more closely. here we have an oceanic and an oceanic convergence. We see land features like trenches and an island arc. Now this one is an oceanic and a continental convergence. We see different land features. We see trenches, which are the same, but we also see a volcanic arc or a volcanic mountain range. And then, of course, continental convergence. And in this, we see the land feature of folded mountains or a mountain range, like the Himalayas. This map is really cool because you can see all of the mountain ranges that are on our planet. And you can see that a lot of them are along the boundaries of the tectonic plates. I like climbing the mountains. Okay, transform boundaries. This is the last boundaries we're going to talk about. At a transform boundary, crust is neither created nor destroyed. They're moving alongside one another. We see earthquakes here, and we also see fault lines. So here's an example of a transform boundary, the San Andreas fault line. There's a picture of it right there on your screen, and there's also a map to show you where this fault line is. This is in the western part of the United States along California. You can see that it almost goes straight through San Francisco, and then it goes to the east of Los Angeles. That looks pretty scary to me. Oh, look at this map. This is cool. This shows the epicenters of earthquakes from 1963 to 1998. Oh, that looks like it follows the boundaries of our 7 major tectonic plates. That's crazy. This particular map shows you volcanic activity. Again, they follow the boundaries of the tectonic plates. This is starting to make a lot of sense. Okay, so here are the major tectonic plates on our planet. If you live in Texas or Alaska, you're in the North American plate. If you live in London, you're in the Eurasian plate. If you live in Chile, you're in the South American plate. Where do you live, and what tectonic plate do you live on? Okay. One of my favorite snacks is a Dilly Bar from Dairy Queen. And guess what? You can look at a Dilly Bar and compare it to our planet, the Earth. They have a lot of things in common. I bet you didn't know. First off, they both have crust. They both have cracks. And they both have a mantle. So the next time that you look at a Dilly Bar, I hope you look at it a little bit differently, because you can see how the crust of the Dilly Bar moves on the surface of the mantle, forming mountain ranges, cracks, earthquakes for sure. Different boundaries as those tectonic plates hit one another. Man, this kind of reminds me about what we were talking about. Plate tectonics. And it's delicious.